All right, this is the marking period 1 test review for stats. We're given a 7-leaf plot, and we're asked how many pumpkins there are. So this is just the count of the pumpkins. Remember, the stem and leaf, they're saying is like 21 pounds. The data represents the weight of a crop of pumpkins. So these are the different weights. If we count up how many weights there are, we can figure out the number of pumpkins. So this is like 06. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So we've got 15 pumpkins. For when they ask us about the mean, this is the average. We find our average by doing the sum, like the adding up all of the values and then dividing by the count. So when I add up 6 plus 8 plus 12 plus 16 plus 18 plus 18 plus 20 plus 21 plus 23 plus 26 29 plus 32 plus 34 plus 38 plus 59. When I add these all up, I get 360. And I'm just still dividing by that count of 15 to get 24. Now, the median is the middle number. Remember, if there's an even count, we have to average the two middle numbers. But here, whether you wrote them all out or you're working on this part here, you could take the count, 15 divided by 2 to get 7.5, and then know that that eighth number is going to be the middle number. Or you can go through and just cross out in order from least to greatest. And then arrive at 21. The mode is the most occurring. Oh, sorry, let me write down. This is the middle number. Our most occurring number is going to be 18. And then we find the range by taking the highest value, in our case 59, and we're subtracting the smallest value, 6, to get 53. So you can expect a stem and leaf plot question similar to this. I'll give you a stem and leaf. You're going to need to be able to describe the count, the mean, the median, the mode, the range. For number 2, it's saying that the Venn diagram to the below, that's a weird way of phrasing, but shows the data collected at a sandwich shop for the last 6 months with respect to the type of bread people ordered, sourdough or wheat. So those are our two options for bread. And the next one is whether or not they got cheese on the sandwich. So use the data to create a two-way table with the answers. Now I think this one could be tricky because we're used to having like the describer, like the category be something like family or friends or cheese and then without cheese. But this circle right here represents without any cheese, and this circle here represents the sourdough bread. So if I'm looking at the table here, when I see the 24 in the middle, the 24 represents that we will have sourdough bread, but if it's inside this circle, it's going to be without cheese. So this is going to be 24. In this circle, we have 26%, and I probably should write this as percent. In this circle here, where outside of the overlap, inside the sourdough circle, if it's not in the overlap of the without cheese, then it does have cheese. So I'm looking at this part in my table. The containing cheese and sourdough is going to be 26%. For the one here, where it's 1% without cheese, I know I'm in the column of without cheese, and if it's not in the circle containing sourdough bread, we said my other option was wheat bread. So I want to be in this column, in the row of wheat. That's where the overlap here is going to go. So this 1% goes here. And this 49% is outside of the circle and outside of both circles. So if it's outside of the without cheese, then it must contain cheese. And if it's outside of the sourdough bread, then it must be wheat bread. So that's where this part is going to go. Oh, sorry, not 1 again. This is going to be 49%. If we're doing this correctly, the sum of the two totals for the rows should be the sum of the two totals for the columns. That's a way we can check these values. So here I'm adding up 26% plus 24% is 50%. 49% plus 1% is 50%. So together this should be 100%. And then below, 24% plus 1% is going to be 25%. So 25% were without cheese. And then 26% plus the 49% is 75%. Which again, I wrote that percent strange, but the 25% plus 75% gets us to 100%. For this next question, a survey of 124 people was conducted at PDC. It was found that 87 persons is a weird way to phrase this. I would have said 87 people carried a cell phone, 14 people carried a tablet, and 4 carried both. So they want us to complete the Venn diagram. In this example, this blue circle represents people that carried a cell phone. This red circle represents the people that carried a tablet. We practiced making Venn diagrams a while ago, and I ran into a lot of people that would have written this as, okay, 87, 4, and then 14. But the problem is, if you were to add these all up, sometimes it was going to go over the 124 people. So, what I'm looking for in this example is to start in the middle, start with the overlap. If we know that 4 people carried both a cell phone and a tablet, they're telling me the overlap is going to be 4. Now 4 plus however many people should add up to the total of 14 people that carried a tablet. So 4 people carry both a cell phone and a tablet. How many people carry just a tablet if in total 14 people carried a tablet? You don't have to write this math on here, but I just want to show you that the number that we're looking for is going to be the 10. So together, 14 people in total had a tablet. 4 of them had a tablet and a cell phone, where just 10 of them had the tablet alone. It's the same idea with, let me just grab a different color, with the cell phone here. Right, we know 87, they call persons, I would have said 87 people, have a tablet. Sorry, 87 people have a cell phone. 4 people have a cell phone and a tablet, plus however many people just have a cell phone should add up to our 87. So by the same idea, I'm going to subtract 4 on both sides. And you don't have to show this math, but just understand that the number that we're looking for that just have cell phones and don't have tablets, this is going to be equal to 83. So now I know that I've got 87 people in total. 4 have a cell phone and tablet. 83 just have a cell phone. I've got 14 in total that have a tablet. 4 have a tablet and a cell phone. 10 just have a tablet. I'm missing the number of people that don't have a tablet or a cell phone, that don't fall into either camp. We were told that there are 124 people. Now, you could approach this like if you wanted to figure out the probability of cell phone or tablet, you could do 87 plus the 14 and then take away the 4 and then subtract that number from 124. I think it might be easier to think about this example like it's 124 and I'm subtracting 83. I'm subtracting 4. And I'm subtracting 10. So in this example here, if I'm taking away 4, this would be like 120. If it was 3 here, this would be 7. And now I've got 110 minus 10. This would be 27. So now I've got every part to here. Originally, I was going to include some questions that asked about like how many people are this and that. But for right now, I think we're just going to, for the time's sake, be setting up and creating the Venn diagram. The next question on here is from the cards. It talks about writing your answer in reduced fractions. I'm going to show you guys like the math frac on there, so we should be okay on that part. For this one here, anytime you see the or probabilities and where you're talking about mutually exclusive events. So we went over those last Friday. What I mean by mutually exclusive is if they're asking me to draw an 8, so these are my 8s, and these are my 9s. There's no scenario where you pick a card and it's both an 8 and a 9 at the same time. So if we know they're mutually exclusive, like there's no overlap on here, then I can just add up the probabilities. So when I'm looking at the probabilities here for an 8, a 9, and a 10, this is 4 out of the 52 total cards, plus 4 out of the 52 total cards, plus 4 out of 52. I can write this like 12 out of 52, or 3 out of 13. Oh, sorry. 3 out of 13. And I can show you with the highlighting. There are 4 for the probability of 8 out of the possible 52 cards. 4 for the 9. And then for the 10s here, another 4 out of 52. For the spade. So a spade is the suit. In this example, it's labeled. I'm going to make sure that if it's not labeled, that I'll put it on the board. But all of these are included in spades. I think there was some confusion when we had one of the quizzes where people were looking at the like not including the face cards like the jack, queen, king. But this is a jack of spades, a queen of spades, a king of spades, and an ace of spades. So there are 13 total spades out of the 52 cards. This is going to be 1 out of 4, which makes sense because there are 4 different suits, all with the same amount. All of them have 13. So when I look at this fraction, it's 1 out of the possible 4 when we reduce it. We already talked about the probability of a 9. This was 4 out of 52. Now, I think this part, their formatting, I think, is a little bit confusing because when they say this symbol here, this is like the complement. And we're talking about, like, not red. If you've played with cards, you'll know that both the clubs and the spades are black cards. The 2 red cards are hearts and diamonds. So this is going to be 26 out of the 52 are not red, or half of them are not red. Both the probability of not 9 and the complement 3 are basically asking the same idea. One way to look at this, instead of going through and counting every card that is not a 9, which is a thing you could do, I would not recommend, but if you're really stuck at this portion, there's nothing that says you can't count up all the cards. Oh, I forgot to erase this part here. So instead of going through and counting up all the cards, it might be easier to think about this like it's the 1 minus the probability of a 9, which is 1 minus 4 out of 52. And you could even type this in your calculator, then hit math frac, but I think it's important that we understand that 52 out of 52 is going to be equal to 48 out of the 52. So this is going to be 12 out of 13. And then the same idea for the complement of the probability of 3 is 1 minus the probability of 3. 1 minus another 4 out of the 52. So we get 48 out of 52. The last question here is saying, in a large school, it was found that 80% of students were taking a math class, 78% of students were taking an English class, and 72% of students were taking both. They want us to find the probability that a randomly selected student is taking a math class or an English class. So we're looking for the probability of math or English. These are not mutually exclusive, and I know that because they're giving us what that overlap would look like. Similar to the example here with the cell phones, because there's people that fall into both camps of having a cell phone and having a tablet, or another example that's not mutually exclusive would be saying something like the probability of a 9, like looking at the probability of a 9 or a diamond, right? If there's this overlap here, we need to use that rule for probability. The general rule is the probability of A or B is equal to the probability of A plus the probability of B, and then we take away the overlap, the probability of A and B. So this is equal to the probability of math plus the probability of English, and then we're subtracting the probability of math and English. So this looks like the 80% for the math class plus the 78% for the English class, and then we're taking away 72%. And you can write your answer as a percent, just like you may answer as a fraction or a decimal. I'm going to delete this part and just talk about the percents on here. So 80% plus 78%, and then we take away the 72%. This is going to be 158. We take away the 62. This is going to be 86%. So again, the test is on Thursday. I've got the video up here. I'm going to post the problems for the people that didn't see it. I think we're going to do great.